Hello guys, welcome to my channel, and let us have a look at this question 6, which I took from May-June 2021. Now this is just an attempt to apply what we have learned in the previous lesson, just to keep going so that this is no longer a problem. Now in the diagram below, the graphs of f of x equals cos 2x. Now if we look at this one, coefficient is 1, amplitude is 1. That means maximum is 1, minimum is minus 1. Okay, so there is our maximum starting at 1, and of course the minimum is going to be minus 1. Okay, so this is approximately where this is. Great. And we can see the graph of f is doing that. So this is maximum over there. No? So that is maximum. And we can carry on with this line. All right. So we can see that gives us maximum and this gives us minimum. So I don't really need to carry on onto this side. Okay, even this side I don't need it. Just wanted to show you guys. I think that is better so that we don't mess up our diagram. Now we move on and say, okay, what's next? We see the coefficient of the angle is 2. So this means our period is the original divided by that 2, which is 180. And we can appreciate that this is the full cup of the cosine function. And can you see it's from 0 to 180? So the period is definitely 180. Even if we look at it on the other side, it's not a big deal. So what else? We can say intervals is going to be the period divided by 4 quadrants. That's going to be 180 divided by 4. That's 45. As we can see, 0, it's an x coordinate at the turning point, the maximum. And now we know that exactly 45 degrees later, we should hit something critical, an x-intercept. And if we take this one down here, we'll appreciate that indeed that is 45 later, that's 90 degrees. And then exactly 45 degrees later, this is 135 degrees. And then 45 degrees later, that lands us at 180. Okay, critical values, like I said, it's either an x coordinate at the turning point. Ignore that this is the y-intercept, even if this is shifted around. I mean, the y-intercept doesn't really matter, as I said. Focus on the x-coordinate at the turning point, and an x-intercept is more important, right? And that's it. So we can see these intervals are doing that. This already tells us that this is minus 45 degrees. And if we see, it looks like these two have a common minimum and maximum value. So this is at the same point. So this is minus 90 degrees. I mean, it looks like it, we're not sure. Again, 45 degrees later, this is 135 degrees, minus 135. And that's it. So we have understood our graph nicely, but just the piece of information given up there. Next piece, we're looking at the G graph. What do we see? Again, we've got a negative 1 there. This means absolute value of that is 1. And it means the maximum is going to be at 1. And if we look at this sine graph, we can appreciate that it's going at 1 as well. So that's the maximum. And the minimum is going to be exactly what we see there. All right, or we can say negative absolute value of that coefficient. And that gives us our minimum. So this is good. And then, of course, if we look at the angle, we don't have a coefficient for the angle, it's just 1. So the period remains 360. And we can see from 0 to 180, we've just completed one half cycle. And if we just take it back So 180 minus 180 gives us 360. So this is essentially a full period. So this is good. Now intervals is going to be 360 divided by 4. And that gives us 90 degrees. And we can see that from 0, which is an x-intercept, forget the y-intercept that is concomitant there. Now from there, exactly 90 degrees later, we hit some critical value, an x at the turning point. 90 degrees later, we are sitting at an x-intercept, and we can move that backward as well. So this is good, guys. So this piece of analysis works all the time. It gives you details of what is probably given, not so detailed. Now, these graphs are drawn for the interval minus 180 and 180. And we are told A and B are the points of intersection of the two graphs. Not a problem. So we can answer some questions. Now question 6, we're going to do 6.1. We are told, without using a calculator, to determine the values of x for when these two graphs are equal. So those are the points of intersection. That means A, B, and that point over there. Okay, so we've got cos 2x equals minus sine x. Now this negative, for me, gives me a bit of a problem. I cannot just immediately change to cos or whatever. So this implies I can just move this to this side. Okay, that is it. And then I will remember that for my three-step approach, this is 1 minus 2 sine squared x plus sine x equal to 0. This is essentially 1 multiplied by that. So we handle the brackets. We can start by minus 2 sine squared x plus sine x plus 1 equal to 0 if we want to write in standard form. Okay, so we can multiply by minus 1. So this is going to be 2 sine squared x minus sine x minus 1 equal to 0. Then we factorize. It almost always works, but when it doesn't, we use the formula. Oops, not squared. Sine x minus 1 plus 1. Don't do this nonsense right now. Now, let's see what is going on here. So this is going to be minus 2 sine x plus sine x. It gives us minus sine x. 2 sine x times sine x gives us 2 sine squared x plus 1 times minus 1. So this is well factorized. So this also implies that sine x is going to be minus a half, or sine x is a 1. Okay, now using my general solutions, it means x is going to be, let's just say minus 0.5 plus k times 360, or x is going to be 180 degrees minus the arcsine of minus 0.5 plus k times 360 degrees. We come to this one. So where k is an element of integers, right? Right. So what do we see, guys? Therefore, we know x is going to be, using special angles, this is going to be minus 30 degrees plus k times 360 degrees. Or x is, this is 180 plus 30. This is going to be 210 degrees times k plus k times 360 degrees, or x is going to be, if we look at this, this is 90, this is 90, so it's the same thing. So this is 90 degrees plus k, where k is an element of integers. So what can we conclude is that x is, now we have minus 30 degrees, right? Let's say k is 0, we've got minus 30, that's within the domain. When k is 0, this is 210, so 210 is outside the domain, 90 is within the domain. So we've got minus 30 degrees and 90 degrees. Now let's see. Let's see what happens when, say, k is 1. So when k is 1, this is 360 minus 330, that is 330, that's outside the domain. When k is 1, this is outside the domain. When k is 1, it's outside the domain, so k cannot be 1. So we cannot continue on the positive integers. We go to minus 1. This is going to be minus whatever, so it's outside the domain. Here, 210 minus 360, that is minus 150. So minus 150 is within the domain, so we can push this a bit. So this is minus 150 degrees, and we take this guy closer, and then we can see this is all, because here 90 minus 360, it's minus 270, and again it's outside. So these are the solutions. Okay guys, so these solutions, the graph is already giving us that impression that indeed this should be one of them. This should also be one of them. And if we want to write, this is minus 150. This should be minus 30 degrees. Great, so that is fine. So we get a mark for each one of those solutions. Maybe, maybe not, I'm not sure. And whenever we factorize as part of our 3-step approach, we sort it out. For me, guys, I would say, from one solution, the set of these general solutions would work. And then from the other one, that one should work. So this is 1, 2, 3, 4, 5, 6. So this is how I believe these 6 marks are done. The rest is really not a problem. Or how can I forget? That should be a mark. That should be a mark. Whenever we use identities, we get a mark. So maybe we can say, we can bunch these. This is 1, 2, 3, 4, 5, 6, 7. This should have been 7 marks though. Okay, maybe we can say, since this was a means to an end, we can give it 1 mark. It's not a big deal. Nice. So this is very easy, guys. But let's just say, for argument's sakes, from this step, you know, sometimes I know how to factorize this thing as it appears. Let's say another student decided to go about this step this way and decided to factorize immediately from there. So this would be minus 2 sine x this would be sine x. Now we have plus 1, so these 2 brackets are negative. And this is going to be minus 2 sine x times 1 is plus 2 sine x minus sine x. It gives us plus sine x. Minus 2 sine x times sine x is going to give us minus 2 sine squared x. That gives us a plus 1. So this implies that sine x is a half. No, not a half. So this is going to be 1 divided by minus 2. So this is minus a half, or sine x is 1. So this is good. Can you see we still get the same solutions? So this would essentially tell us that x is going to be minus 30 degrees plus k 360 degrees, or x is going to be 210 degrees plus k 360 degrees, or x is going to be 90 degrees plus k 360 degrees, where k is an element of integers. And from there, we can say x must be the set of these values: minus 150 degrees, minus 30 degrees, and 90 degrees. So it doesn't matter, guys, what approach you chose, as long as the maths ties up nicely, we should be fine. If the maths doesn't tie up nicely, then we have a problem, okay? So that's about it. So always think of options and how to do things differently, and just check in case. Let's say, for example, we were not given this graph. This technique already gives us the answers without any questions, even that technique. So you just need to know. Most important is writing in standard form. It doesn't matter whether you modify that or not. Standard form is key, guys, because it helps us to proceed. Okay, let's not sit on that. So we've got 6.2 with 6.2.1. Now, we are told to use the graphs come on. Use the graphs. Now, this is a very strict instruction. Sometimes it's not highlighted so that you miss the idea. How many degrees apart is points A and B from each other? So basically just tells us what is the size of AB. Now we can clearly see there from these solutions that this is nothing but, we can just take 30 minus 30 degrees minus into minus 150 degrees. This is going to be equal to 120 degrees apart. At the end of the day, we answer the question. So one can get a mark for that and a mark for the second stuff, but a 2-mark question, answer only, is good enough. So 6.2.2 says, for which values of x in the given interval is this situation the case? Now, once you see derivatives, it already tells us that we are talking about gradients. Okay, so gradients, you just draw a tangent on the graph. So we can clearly appreciate that this is a negative gradient. If we draw a tangent over there, we can appreciate just a local tangent. We can appreciate that that's a positive gradient. So now for this product to be greater than 0, it means it's either these two are both positive or both negative. So let's have a look. When do we see that? From 0, if we scan to the right, this gradient is negative, as well as that gradient. But at the turning points, the gradient is 0. So that's not allowed. And then if we go up, these gradients are positive, so that's allowed. But at the turning point, that gradient is 0, while this one is positive. So 0 is not included. So it means we need to look at this interval, excluding the values, as well as this interval, excluding the values, because again, if we draw the tangent at that turning point, it's 0. Okay, so that's it. And if we look before that, we can appreciate this is a positive gradient, that's a negative. Now the product is negative. And this keeps on happening because the gradients are just not the same. They keep disagreeing. So we don't worry about that side. So we can write our solution that x must be less than 90 degrees, greater than 0 degrees, or x must be less than 180 degrees, greater than 90 degrees. So the most important is that those values must be excluded. Easy, 2 marks. Now the last question, this is 6.2.3. We're told to determine the values of k for which this will have no solutions. Okay, now we always try to make this look like what we see. So we can see this cos 2x plus 3 equals k implies that cos 2x is equal to k minus 3. But now we are saying no solutions. So what do we mean? It means this business right here. Remember, cos 2x has a maximum at 1 and minus 1. Now, if this is not to have solutions, it means this thing must be outside that range, right? So this implies that k minus 3 must be less than minus 1, or k minus 3 must be greater than 1. So where did we get these? This is the minimum value. This is the maximum value. So we're still using the graph. So therefore, k must be less than, when we transpose, it's going to be 2, or k must be greater than 4. Nice and easy. Nice and easy. So this is very easy, guys. It's not complicated. It's something to just chew upon very quickly. So what would be the other way to deal with this situation? You know, always explore your options, guys. It helps a lot to do so. So of course, we're getting a mark for each one of those solutions. And the third mark is, I'm trying to think now, deriving these inequalities, is it really helping? Not too sure. Not too sure, but I would give a mark for that, because this step is not really, that's just manipulation. Now guys, most likely if we look at this graph, we can see that this is vertically shifted upward by 1 unit. So we can use the graph to do this. Okay, so if we shift the graph of course by 3 units upward, what do we mean? We will end up with some value there, which is a 4, right? Because the minimum is going to be minus 1 plus 3. It takes us to 2. Okay, so this means our graph is going to be at a maximum here, minimum there, and reach its max. Then again, it's going to do this thing, minimum there, and then its max. Of course, guys, this is not quite nice. This is not quite nice because, I mean, it's a freehand drawing, so that's the idea. So we just show that graph that it's going to have those minima and maxima. Now clearly, if k is anything below those maxima and minima, because this is a horizontal line, it does not intersect that graph. And again, if it is going above that line, it does not intersect. So from here, we can just write an answer and say, therefore, k, must be less than 2, or k must be greater than 4. So we can use the graphical method, understanding that this is a vertically shifted graph of f by 3 units. So we can even label it and say this is f of x plus 3 to show that we have shifted that graph. And coupling that with some k value, we could really do so much better. So guys, always know how to do things. as long as you get it done. So this is 3 marks, and that ends our look into this question for a total of 13 marks. Okay, I'm running out of space to write, but I do hope and believe you have learned something, and that now you can approach any trigonometric function related question with ease and no panic. Of course, questions can come in different forms and with different levels of difficulty and challenges, but if you keep this basic knowledge and basic approach to these kinds of questions, this enhances your understanding of what is going on, so that you don't just go through the motions. It's easy to train people to do things, but if they don't understand, then they will never know when they need to make adjustments. So the purpose of these lessons, guys, is to give you a real understanding of the situation, so that as you proceed in your maths, you become unstoppable. Because if you go to university or college, remember, you're going to get more complex material, which actually underscores most of what we are doing right now, because we're purely applying what has been generated by what you're going to go into. Now, the problem is you will not understand those things. So it is very important to make sure that you have a very solid foundation. Metric is supposed to sum up all your schooling years, your 12 schooling years, meaning you must understand each and every section, every component of the subject, so that as you proceed, you have a firm foundation, so that your knowledge becomes very clear, even at varsity. When you start to do more advanced things, you will start to understand those things better, because you know where all of this comes from your lower grades. And you will start to be creative, to see beyond what is being taught. And this is when we create inventors, people who come up with new ways of doing things, better ways, in fact, than we have previously been, using. Anyway, guys, I will talk until Jesus comes. Otherwise, I hope you enjoyed the video, and good luck with more practicing. Please do yourself some justice. Practice by yourself. Get stuck. Try your best. Read notes. Double check. Check everywhere before you look at the solutions. Make sure you've exhausted most of your sources of information before you give up and say, I want to see the memo. This one is just a worked example, as would be done in class by your teachers. But what is important, if you're a smart student, when you see this question, you will attempt it before you watch the video in its entirety. Or watch the video, then scrap everything, try that question by yourself. Because again, it helps to approach a question with confidence, so that you can see beyond what you have been shown. So watching it first can help to get you where you need to be. Then try using every other method or technique you can think of, and see if you're going to solve it to the same solutions as I have, and to make sure you understand each and every step, what it stands for and what it means. Otherwise, guys, I'll see you some other time. Goodbye.